Welcome to the first of two videos on the applications of right triangle trigonometry. The goal of this video is to solve right triangles. Many real-life applications do involve right triangles. The real-life application problems will be in the next video. This video will review how to solve a right triangle. To solve a right triangle means to determine the measure of all three angles and determine the length of each side. Two basic ideas we should already be familiar with are the Pythagorean theorem, and also that the angles of a triangle have a sum of 180 degrees. So let's solve this right triangle. So the first thing we have to recognize is we have a right triangle, so this measures 90. This measures 36.87 degrees. We know that the two acute angles of any right triangle are complementary. So to find angle B, we can just take 90 degrees and subtract 36.87 degrees. And we can see that would give us 53.13 degrees for angle B. Next, we're missing this side of the right triangle, and we can use the Pythagorean theorem to figure out the missing side here. Remember that c squared is equal to a squared plus b squared, so we would have 15 squared equals 9 squared plus x squared. Let's isolate x squared. If we subtract 81 on both sides, we'd have 144 equals x squared. Square root both sides of the equation. X equals 12. So AC is equal to 12 units. And we have all the angles and all the sides, so we've solved the right triangle. Let's go ahead and try another. We have a right triangle, so these two angles are complementary. So 90 minus 62 would give us angle A. That would be 28 degrees. Notice on this triangle we only have the length of one side, so we can use trigonometry to determine one of the two other sides. Let's go ahead and try to find the hypotenuse first. What we'll do is we'll use this angle that we know is 28 degrees, and we can figure out how we can relate this angle to this leg and this hypotenuse. And if we say that the cosine theta, or cosine 28 degrees, would equal the adjacent side over the hypotenuse. So 7 over c. And now notice we only have one unknown. So now we can use the calculator to find the value of cosine 28 degrees. Make sure your calculator is in degree mode. And we'll use 4 decimal places, so 0.8829 is equal to 7 divided by c. So if we multiply both sides by c, we'd have 0.8829c equals 7, so we need to divide. This implies that c is approximately 7.9 units. Now we still need to find the length of side A, and to do this I'm going to use this angle again, but I'm going to use tangent this time. I'll say the tangent of 28 degrees equals the opposite over the adjacent side. So we would have tangent 28 degrees equals A over 7. Now one reason I didn't want to use c is because I knew this was a rounded value. So if I use a rounded value, it will cause more of an error when we find the length of A. So the tangent of 28 degrees is approximately 0.5317. Here, if we multiply both sides by 7, we will have the value of A. Looks like it's approximately 3.7 units. Now we have a solved triangle. We have the measure of all the angles and the length of all the sides. So we're done. Let's try one more. Notice on this problem we're missing the two acute angles, so we're going to have to use one of the inverse trig functions to find the measure of angle A or angle B. So let's go ahead and use angle A. Using sine, we'd have the sine of A is equal to 5 over 13, or the opposite over the hypotenuse. Now if we take the arc sine or inverse sine of both sides, And on the left side, the inverse sine of sine A just gives us angle A. And on the right, we can go to our calculator and determine this angle. Remember, inverse sine is second sine, 5 divided by 13. And the angle is approximately 22.6 degrees. So if angle A is 22.6 degrees, or approximately, we know these two are complementary. So 90 minus 22.6 would give us 67.4 degrees for angle B. Right triangles can be used to find the distances if the angle of elevation or depression is known. So if this horizontal line represents the line of sight, looking upward, this would be the angle of elevation, or looking downward, this would be the angle of depression. Let's go and take a look at a couple problems. Juan's eyesight is 5 feet 6 inches from the ground. When he stands 100 feet away from the flagpole, the angle of elevation is 45 degrees 48 minutes. What is the height of the flagpole? So let's go ahead and sketch what's happening here. If this is Juan, then let's call this the line of sight. This would be 5 feet 6 inches. Let's convert this to a decimal. So this would be 5.5 feet. And he's standing 100 feet away from the flagpole. So over here, 100 feet, we have a flag. And the angle of elevation, this angle here, is 45 degrees 48 minutes. Let's go ahead and convert this 48 minutes to a decimal. So we would take 48 and divide by 60. That's going to give us 0.8. So we have 45.8 degrees for our angle of elevation. And the question is, what is the height of the flagpole? So we can figure out this distance here. Let's just call it y. And then we can't forget that we do have to add this extra 5.5 feet to find the total height of the flagpole. So we have a right triangle here. What we can see that this is the opposite side and the adjacent side to the given angle. So we can say the tangent of 45.8 degrees must equal y over 100. So if we put this over 1, we could just perform cross products. 1 times y would equal y, and y will equal tangent 45.8 degrees times 100. Make sure your calculator is in degree mode. Times 100, and 102.83 feet. Now be careful, that's not the height of the flag, because we still have to add 5.5 feet from his line of sight to the ground. So the total height of the flagpole would be 108.33 feet. A 12-foot ladder leans against a building, so the angle between the ground and the ladder is 72 degrees. How high will the ladder reach? So if this blue rectangle is our building, this would be the ladder that has a length of 12 feet. And the ladder forms a 72-degree angle with the ground, which means this angle here is 72 degrees. To determine the reach of the ladder, we need to find the length of this side of the right triangle formed by the building, the ladder, and the ground. So let's call this length x. To find this length, we'll have to use a trig equation, but first we have to decide what trig function to use. Using the angle of 72 degrees, notice how x would be the length of the opposite side, and 12 is the length of the hypotenuse. And since the sine function value is equal to the ratio of the opposite side to the hypotenuse, we must use the sine function in our equation. The equation will be sine 72 degrees must equal the ratio of the opposite side to the hypotenuse, or in this case, x divided by 12. So to solve for x, we'll multiply both sides by 12. Notice this simplifies to 1, so we just have x on the right side. And now we'll go to the calculator to approximate this product. It's important to make sure that we are in degree mode, so I'm going to press the mode key. Notice how we are in degree mode because it's highlighted. Now I'll go back to the home screen and type in 12 sine 72 degrees. So x is approximately 11.4 feet. Which means the reach of the ladder is approximately 11.4 feet. Here's an application of a trig equation. You are standing 42 feet away from a tree. Your line of sight is 5 feet from the ground. If you measure the angle of elevation to the top of the tree to be 43 degrees, how tall is the tree? Since you're 42 feet away from the tree, this distance here would be 42 feet. Your line of sight is 5 feet, so the distance from here to the ground would be 5 feet, where this would be the ground. The angle of elevation to the top of the tree is 43 degrees, which would be the measure of this angle here, 43 degrees. So to determine the height of the tree, we'll have to do two things. We first need to determine the length of this side of a right triangle. Let's call this x. And then we'll have to add this length to the length from the line of sight to the ground, which again is 5 feet. So if we let h equal the height of the tree, it would be x plus 5. So now we can set up a trig equation to determine the length of x. Since x is the side opposite the angle that measures 43 degrees, and this side here is the adjacent side, we can use the tangent function to write an equation to solve for x. The tangent of 43 degrees must equal the ratio of the opposite side, x, to 42. Now if we make this a proportion, we can cross multiply and solve for x. X times 1 would be x must equal 42 times tangent 43 degrees. And now we'll use the calculator to determine this product. Let's check our mode. We are in degree mode. So now we can just type in 42 times tangent 43 degrees. And so x is approximately 39.2 feet. But we're not quite done. Remember, the height of the tree was equal to x plus 5. So the height of the tree is equal to 39.2 plus 5, which is equal to 44.2 feet. So the height of this tree is approximately 44.2 feet.